In this lesson, we shall focus on mathematics, polar curves, Math 141, Mathematics 1B, Tutorial 10, polar curves. And we are starting with the following. I want us to first discuss some background on the families, right? The families of Rose curves, right? There are certain things we call the Rose curves. Let us discuss Rose curves here. Now, the notion of Rose curves actually stems around if we see a curve that is R equals A sine n theta. R equals A cosine n theta. A sine n theta. And then we also look at A cosine n theta. Okay, these two curves themselves are called the rose curves. And these two curves look like roses. And I want us to therefore have an opportunity to discuss this idea of roses. Let us discuss some of these. We have basically the 5 basic shapes. If we're dealing with R equals A sine n theta, what is the first curve here? The first curve looks like this. So you can do this. You do a rose. You put another rose, and another rose. This would be the curve whenever n equals 2. Right, whenever n equals 2, then it becomes a rose. So these curves of A sine n theta and A cosine n theta, all of them are roses. But when n equals 3, it becomes a different rose, but of course a rose. So now you'd have this one that is going to be like some rose petals. So you'd have a rose here. You would have another rose here. And then another rose here. N equals 4. You therefore have 1, 2, 3, 4. Let me draw carefully. So for instance, here we have double roses in each quadrant. We have double roses in each quadrant. Like so. Okay, I'm trying to cover some theory so that it can be easier to sketch these graphs here. And then now this n equals 5. Okay, because now you see, obviously then the n can be, like here, the n is equal to what? Like here, the n is equal to 2, but obviously it is for the cosine. So let's look at n equals 5. Okay, I want us to sketch this particular curve here. Right, so you have this one. You have this one. We have this one. We have this one. We have this one for n equals 5. And then there's another one for n equals 6. Right, so for n equals 6, you're going to have the following. 1, 2, 3. You have 1, 2, 3. You have 1, 2, 3. You have like triples in each region, like so. And then you also have 1, 2, 3. Okay, this is for the n equals 6. Just looking at some of the curves, we call them rows curves. Take a look at the rows curves and make sure that you understand them. If n is 2, you have 2. If n is 3, you have 1, 2, 3. If n is 4, you have 2, 4. If n is 5, you have 2, 4, 5 roses. If n is 6, you have 3, 6. Okay, obviously these are the rows curves for the sign, but we're speaking about the families of rows curves. Let's look at the next one. R equals A cosine n theta. We're still speaking about rows curves, but I want us to cover enough background on sketching. Okay, we're going to use the tables and other techniques of sketching these curves here. Okay, let us look at the first one for the cosine. Right, for the cosine, then you have this one. So you have a total of 2, 4, 5. Right. We have 2, 4, 5. Perhaps let me make them a little bit equal to each other. So you can have 1, 2, 3, 4, 5. And so you'd have therefore, which is 1, 2, 3, 4. And so this one is n equals 2. You have 1, 2, 3. Then now you have the threes. For n equals 4, for the cosine, you have 1, 2, 3, 4, 5, that, and that. N equals 5. This, this, that. And then there's n equals 6, which is gonna have the 1, 2, and then you have the doubles. The doubles in the quadrants. So you have the doubles that appear in the quadrants. So you have the doubles that are in the quadrants. That way. So this is for n equals 6 for the cosine. These are the graphs we have. But for n equals 3, let's check. Okay, and for n equals 2, for n equals 2 for the sine, you can see that these roses are like in the middle of the quadrants. Like this is a quadrant, then the rose is in the middle. It's in the middle, it's in the middle. But for the cosine, still, I mean, for n equals 2, you have 4 roses. But for the sine, it's in the middle of the quadrant. But for the cosine for n equals 2 is on the axis, like it's on the y-axis, it's on the x-axis, etc. And it's on the x-axis, it's also on the y-axis. So for n equals 2, you have 4 roses for both the sine n theta and the cosine n theta. But for the sine, it's in the middle. But for the cosine, it's on the axis. Let us check n equals 3. For n equals 3, for the sine graph. Okay, the sine polar curve for n equals 3 is such that it is again in the middle, with the exception of the bottom one that is actually on the vertical axis there. Okay, n equals 3. For n equals 3, for the cosine, it's in the middle, but let us look at the middle, because the sine is positive in the first and the second quadrant. So it's in the middle there. Wherever the sine becomes negative, this curve is going to be on the vertical axis. But in the quadrants where the sine is positive, it's going to be in the middle, etc. Okay, I'm looking at the quickest way to sketch this without wasting time. For n equals 3 is the same. Right, when you look at the cosine is actually positive in the first and also the fourth quadrants. Yet this rose is therefore going to be on the positive ray, because the cosine is positive here. But where it is negative, it is in the center. It is in the middle of the quadrants. Right. It is contrary to the sine, because wherever the sine is positive, then it is in the middle of the quadrants. Wherever the sine is negative, it is on the vertical axis. But with the cosine, it's contrary to that. It actually takes a different turn, and it says that whenever the cosine is positive in the first and the fourth quadrant, it is on the horizontal axis, on the real axis. But on the other axis, it is what? It is actually exactly in the center of the quadrant. Okay, let's just look at the fourth for the sine. N equals 4. You can see double roses, like 2, 4, 2, 4. Double roses in each of the quadrants. There's a double rose in the first quadrant, double rows in the second, the third, and the fourth, double roses, giving a total of 2, 4, 6, 8 roses. 8 roses for n equals 4 for the sine theta. For n equals 4, you actually now see that for n equals 4, you have 1, 2, 3, 4. Yeah? 1, 2, 3, 4. All of them are like cardinal roses. They are on the axis. And then you fill in with 1, 2, 3, 4 that are in the middle of the roses there. Okay, but now let's take n equals 4 for the sine. Right, for n equals 4 for the sine, nothing is on the axis actually, but what you're having is that everything is in the middle for the sine. Okay, the sine likes being in the middle, so the double in the middle, etc. And then now when you're looking at the n equals 5, you have 2, 4, 5 roses, but the one of the roses is actually on the positive vertical axis, but also you are seeing the 1, 2, 3, 4 that are in the middle of the quadrants. N equals 5, you have 2, 4, and 1 is on the horizontal axis, but also because the cosine is positive in the first and also the fourth quadrant. So this obviously lies between the quadrants in which the cosine is positive. And if that is the case, lying on the horizontal axis, then you have 1, 2, 3, 4. This one, the sun is positive in the first and the second quadrant, so this rose is there, and then the other roses are just playing around there. N equals 5. For n equals 6, you have 3, 6, 3, 6. For n equals 6, you have 2, you have 1, 2, 3, 4. Double, 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 double. Okay. So we continue. We continue. Okay, yeah, this was just a summary of the rose curves, but there's more I want us to cover as some background. As some background. As some background. All right, as some background here. So now there are other things that you need to obviously take note of here as you cover these particular notions. It is very important to ensure that we also look at the limacons. Limacons. Let us look at the limacons. At the limacons. At the limacons. Okay, we're gonna actually look at the limacons now because I'm trying to look at what the textbook is saying about this curve sketching. And how can this curve sketching be simplified, you know? Now, this is very important for us. How this can actually be simplified. This is very, very important for us. This is very, very important for us. Right, so let us discuss these. Let us discuss these. Right, let us discuss these notions. We discuss these notions. Okay, now there are things we call limacons. Okay, let's look at the limacons and discuss what the limacons are and how these limacons are sketched. Okay, before we look at the tag problems. So the things, they're roses, they're shapes, we call the limacons in the polar curves. So let us talk about limacons and what you need to know about the limacons. But first, we discuss what we call families. Families of cardoids. Families of cardoids and limacons. Families of cardoids and limacons. Right, and limacons. Which is A plus or minus B sine theta. B cosine theta. So you do right, so and then you have this. So we studied the four shapes. And then this one is going to be the A over B is less than 1. Okay. And then there is A over B equals 1. You have 1 less than A over B less than 2. A over B greater or equal to 2. So this one becomes a Limacon. Limacon with inner loop. Limacon with inner loop, this one. This one is called a cardoid, like a heart. This one is called a dimpled Limacon. It's called the dimpled Limacon. Dimpled Limacon. And this one is called a convex. Convex Limacon. Right. Limacon with inner loop. Cardoid. Dimpled Limacon. Convex Limacon. Right. So take a look at this. Right. So the word Limacon, Limacon, or the word Limacons is actually from Latin. It's actually from Latin, from the Latin word. From the Latin word. Limax. Limax for the Latin word is limax. Limax for a snail. Snail-like creature. Snail-like creature. That is commonly called a slug. A slug. S-L-U-G. A slug. S-L-U-G. A slug. S-L-U-G. A slug. So right. Right. So we continue with our investigation of these. And I want us to speak about the Limacons of R equals the R equals A plus cosine theta. We're going to draw like so many of them. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So that is one shape. There's this one here. And then there's this one, small one. But now this one is when A in this equation is 0.25. When A is 0.5, you have this one. Okay, then you come to this. When A is this small one is when A is 0.75. And then there's this one that is like it is no clear hole here. Is when A equals 1. So it's like 1 plus cosine theta. And then you have a case when A is 1.25. So you have exactly this. 1.5. 1.25. 1.5. Okay, so there's this one here a little bit like straight, which is A equals 1.75. Then there's A equals 2. And then there is this one that is a little bit almost a perfect circle, but it's oval. It's oval like an ellipse, which is 2.25. And then there's this one that is like a perfect circle. Perfect circle, and it is A equals 2.5. Like this. So let us think about this. Okay, so these are some of the limacons of the graph. A plus cosine theta. A plus cosine theta. A plus cosine theta. So that is what you're able to notice there. That is what you're able to notice. But let us continue with our search and understanding. Okay, I'm trying to look at the textbook's approach to the shapes so that you're able to relate to, because for instance, at 0 point, when A is 0.25, it has a big loop inside. But when A is like 0.5, It is a smaller loop. But if A is 0.75, close to 1, it's a little bit, okay, yeah, it's very small. So you can see the A is increasing. But the smallest one, which we're noting at 0.25, it's big. The inner loop is like so big. But now when you take, because you can see it's increasing, 0.25, that is like 1/4, this one. And this one is like 1/2. At 1/2, it's a bit smaller. At 3/4, a little bit smaller. At 1, there's no loop. It's just like a dot. At 1 1/4, 1.25, it is like now migrating away from the origin, but it forms a smooth curve. At A equals 1.5, it is similar to 1.25, but now it's becoming smooth and smooth, because at 2.5, it's like a circle. It is like a circle there. So this would be, whenever we need to draw a curve like this, A plus cosine theta, but yeah, they've not put that one there. Okay, we're just having some summaries of the curves, but we're gonna see what to do next. So, right, we continue with our search for the truth about this sketching. So now we're gonna have to make sure we have a perfect understanding of this, and we're able to write. You're able to make the most of these. Right, we're able to make the most of this. But now we are continuing with our search. This is just a summary of the kinds of things we need to note, and also the kinds of things we need to understand when we deal with, when we deal with the Limacons. Because Limacons is Latin. It's a Latin word that refers to the snail-like structure we call a slug. So this is just a summary of this. I want us to get to the bottom of this in today's discussion and make the most of it, because that is what is going to make us better citizens. Right, that is going to make us better citizens. So we continue. We continue. We continue. So, okay. There are more things I want us to explore about this curve. To explore about these curves. Right, there are more things I want us to explore about these curves. Right, there are more things I want us to explore about these curves. Right, 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 right. Okay, I want us to discuss the things we call symmetry tests. Symmetry tests. So A, the symmetry about the x-axis. B, okay, symmetry about the x-axis. Replace, what do you say, replacing replacing theta by minus theta produces same equation. Produces same equation. Okay, so now there's another symmetry. The symmetry about y-axis, about the y-axis. Okay, because we're going to be using this in sketching, because if it's symmetric about the x-axis, then we know that it's going to be the same on either side of the axis. So we're saying symmetry about the y-axis, replacing theta by pi minus theta produces same equation. C. The symmetry about the origin. All right, symmetry about the origin. Symmetry about the origin. Replacing. So here, theta becomes minus theta, means same. Here, theta becomes pi minus theta, makes the same. In this case, symmetry about the origin. Replacing theta by theta plus pi. All right. O r by minus r produces same equation. All right. Let's continue. So now, symmetry about the x-axis means that when you make theta a negative theta, the equation remains the same. For the curve, for the kind of equation that is symmetric about the x-axis, but the symmetry about the y-axis, if you replace theta by pi minus theta, the equation remains the same. Okay. Also, when you replace theta by theta plus pi, okay, so you're able to see that about the y-axis is theta replaced by pi minus theta. Theta is replaced by pi minus theta, produces the same thing. But, right, okay, yeah. Okay, let me see. Let us deal with the symmetry about the origin. What do we do with symmetry about the origin? So, symmetry about the origin, replace theta by theta plus pi, or you can say replace theta by pi plus theta. Or you replace r by minus r, the equation remains the same. This means the symmetry about the origin. Okay, so these things are very useful when we sketch the graphs. They're very useful when we sketch graphs. Okay, so this is very, very important for us. Very, very important for us. So the question then is, what do we do when we sketch the curves here? What do we do when we sketch the curves? The best way to sketch the curves is to sketch two graphs. The textbook is clear that you must sketch two graphs. If you sketch the two graphs, then you can easily be in a position to sketch the curve. Let us take a look. Okay, now I want us to discuss the tutorials in detail, but in relation to how to sketch polar curves accurately. We start with the r theta curve. R theta curve. So we're going to sketch these graphs here adjacent each other. So we're going to have this one that we're also going to sketch here, like so. Like so. Right, so you have this one that we're going to sketch. But remember, we're sketching the things between 0. Okay, I want us to sketch the dimpled Limacon, A. But now we're starting with the sketching, and we're using the techniques in the textbook by Anton. And now we're going to start with this one. Let us start with this one. But we're going to sketch, and then we have pi over 2. And then you have pi. You have 3 pi over 2. And then you have 2 pi. And this one becomes the theta axis. Whenever the cosine of theta is 0, whenever the cosine of theta is 0, you put use a calculator. Cosine 0 is what? Is 1. So 3 times 1 is 3, giving us 7. So this is going to be like 7. Whenever theta is pi over 2, cosine 90 is 0. Cosine pi over 2 is 0. And this is going to give us what? It's going to give us only 4. It's going down. At pi, it's going to give us cosine pi, which is minus 1. 4 minus 3, it's a 1. At 3 pi over 2, okay, so yeah, this is going to be a 7. At 2 pi, it's going to be 7 again. So the kind of graph you have is this one. Is this one here. Okay, you sketch the r theta graph, but it's not what they want, because now we're going to do the polar curve. But what you do is you draw some horizontal lines. So you can draw some horizontal lines here. And then you do at 4. And then you do it this one. You do it pi. Yeah, then you're gonna do pi over 2. Right, you're gonna do it pi over 2, then you're gonna do this. So you do quickly this one. Okay. Then you have the horizontal line, but the graph is red. The graph is the red one. Now you use this. So you start at 0. At 0, you can see it's gonna be exactly 7. 7 is sort of the biggest distance from the equilibrium position. So you have 7. Just take it from there. So this 7 now is going to be at theta equal to 0, then you have 7. At pi over 2, it is 4. Pi over 2 is here. You have what? You have a 4. So r theta, you put the r and then you put pi over 2. So you're going to be here and there. And then you note what is happening here. Between 7 and pi over 4, you can see a decrease, but a constant decrease. Okay, so the distance was this, but it's not going to 0, but it's becoming smaller and smaller and smaller until you reach 4. So this is the shape. Okay, let's make it clear. Let's make it clear. Then now we're going to look at 4. And then there is also up to pi. At pi, it is 1. But because it's on the negative side, then this 1 becomes a negative. So you're going to have a point here. But what is happening between pi over 2 and that? There is a decrease. The radius is 4. The radius decreases to 1, but it is just decreasing. So the radius is 4, and then now it becomes 3. It becomes 2. And then it moves to a point where our r becomes a minus 1. There. Okay. So you have this. Then at this point, between pi and 3 pi over 2, there is an increase. Between pi and pi over 2, there's an increase. But now you can see that this increase is an increase. It's an increase. Now this increase then is going to be increasing in the following manner. So when theta increases from pi to 3 pi over 2, theta is pi here, and then it increases pi over 2. So this one is r, and r is -1, and that is theta. So here you have r. R is what? R is 4, and the angle is 3 pi over 2. Okay, let's continue with our search for this. Right, so now at pi, then you have 3 pi over 2. At 3 pi over 2, it is obviously a 4, but now it is increasing in the other. Now, once again, you saw that this was 7, and then there was a decrease. Then this side, you're able to see that what we're actually seeing, that as theta itself increases from pi to 3 pi over 2, the radius r appears to then also increase. The radius was -1, and then you really can see, therefore, from -1, it will then become a -4. Right, and it goes on and on until 2 pi, when it becomes 7 again, but it is a -7, because it was a -1 there, increasing from -1 gradually, or rather sort of, what you can say, most importantly, is more of a decrease. It's more of a decrease there. obviously, because you can see there's an increase in the negative direction. An increase then in the negative direction is equivalent to, in particular, from pi to 3 pi over 2, we can see the negative r. But from 3 pi over 2 to 2 pi, it is exactly moving from minus 4 for r, and at this point, then it becomes exactly a 7. It becomes exactly a 7 at 2 pi. And the 7 at 2 pi becomes indeed a positive there. And therefore, this would be the shape. What more can we see about this graph? There is, if we replace theta by minus theta, the graph is the same. The graph is the same. The graph is the same. So if the graph is the same, it means therefore that this graph is symmetric about the x-axis. Meaning about the x-axis, the upper graph is the same as the graph at the bottom. The graph at the bottom. And you can see also symmetry about pi here. Whatever you have on this, on the left of pi is the same as what you have on the right of pi. Let's move on to the next graph. Okay, so we're going to try this one using the same interpretation. R theta. Okay, we're going to do 0. We're going to do pi over 2 pi, 3 pi over 2, 2 pi. When theta is 0, you have 3. Because sine 0 is 0. But at pi over 2, then it becomes 1. Let's move up. Let's move the 3 up. Let's move the 3 up. At pi over 2, then it becomes 0. Rather, the sine of pi over 2 is 1. Okay, so you have these points. You just do the r theta graph in your scripts. It's quick. And then the sine of pi, the sine of 180 degrees is what? It's 0. And therefore this is as 3. Okay. So the graph is going to be doing something like this. A 3 pi over 2 is a minus 1. Which is going to be minus 2 times minus 1, which is just going to be 2, giving us a 5. At 2 pi, it is 3. At 2 pi, it is 3. At 2 pi, it is 3. Okay. At 2 pi, it is 3. And then this is sort of the graph you're having. So you have this, that, pi over 2, pi, 3 pi over 2, 2 pi. Okay, let us think about this. Let us think about this. Let us reason about this. Right, let us reason about this. Okay. Then we're gonna, okay, I wanted to sketch the other one. I wanted to sketch B. So because I put the B here. So let's be quick. So we're gonna have 0 pi over 2, pi 3 pi over 2, 2 pi radians. At 0, the B is gonna be a 3. The pi over 2 is 1. At pi, it is 3, because the sine of 180 is 0. Right. So we're going to have the following. You're going to have the following. Right. Okay. Yeah, so you have this. So this one, at pi, yeah, it's going to be a 3. At 3 pi over 2, it's going to be, because the sine of 3 pi over 2, it's minus 1. So minus 1 times minus 2 becomes a 2. 3 plus 2 is a 5. So it's going to be a 5. It's going to be a 5 thing. And at 2 pi, okay, yeah. Sine 2 pi is 0. It's taking us back to 3. All right. So let us examine this one. So if this one, pi, 3 pi over 2. Right, so we have the following. We continue with our sketching. Let us see now. We're looking at the blue curve. And we are analyzing what is happening. Like at 0, it is 3. So you have r is 3, theta is 0. And then there's pi over 2, it is 1. Right. Continue. So the 3 pi over 2, then you have a 1, you have a 3. But you can see then there is a gradual decrease, yeah? There is a decrease from 3 to 1 in in r, because this is r theta. There's a decrease in the radius as theta increases. As theta increases, r decreases. As theta increases between 0 and pi over 2, the radius decreases. So what you're able to see is that the radius sort of decreases. Plus 3, and then it becomes 1. Now the radius between 0 and pi, like what is happening at pi? At pi, it becomes 3 again. But this 3 at pi is on the other side, so it is negative. Negative. But this pi, this r was 1, and then now it becomes 3. But on the other side, you can see a gradual increase there. Between pi and 3 pi over 2, there's sort of a gradual increase from 3 to 5. But it is on the other side of it is on the other side of pi over 2, for example. But also it is on the other side of pi. Right, and on the other side of pi, between pi and 3 pi over 2, you have you have negatives. So it's going to move from 3 to 5. It's going to move from 3 to 5. But on the negative. And then now it's going to move from 5 to 3. Between 3 pi over 2 and 2 pi. It's going to move from 5 to 3. So this will sort of be the graph there. This will sort of become the graph there. Okay, what are we saying here? What we are saying here is that to draw all these graphs, you just need to draw an r theta graph and then translate everything to the polar graph. That is the textbook's approach to this, and I believe it's easier. Let us look at what are the steps that we need to take when it comes to sketching these graphs. We need to always have theta and then r. And then you have 0, you have pi over 2, you have 3 pi over 2, you have pi first, which is like 180 degrees, so you can always sketch this one. So you don't need to sketch a lot of steps that are going to be very confusing for you. You have pi radians. Three pi over 2, 2 pi. Okay, so you do this one, like this is r. When at 0, it becomes 3. Pi over 2 becomes 1. Pi becomes 3. 3 pi over 2 becomes 5. 2 pi becomes 3. So you take these things and you plot them here, and you quickly can be in a position to look at the decreases, the increases, and so on. Now, this is what we do. But now you need to just draw these tables at pi at 0, pi over 2, pi, 3 pi over 2, and so on, until we're able to find a case where this can be a little bit difficult, maybe. I mean, there can be cases where you might need more details, you know. And let us think about this, because there are cases where you might need more details when it comes to the curve sketching. So we'll obviously get to investigate that part and see exactly what we need to do when we need to When you need to sketch, what we need to do when we need to sketch. Okay, we continue with our quest for sketching polar curves. We look at the next one, and we attempt to see how best we can sketch as well. And the kinds of features of the curve that remain very important and what you actually need to know. Right, and actually what you need to know. Right. Okay, we continue with our sketching. We look at the next one. We're done with B, and then we're gonna look at C. How do we sketch R squared? To get sketch R squared, you need to take the square roots. We need to solve for R, and if we take the square roots, then we proceed from there, but in a step-by-step and very organized fashion. Okay, that is what we're gonna do in a case like this. Okay, let us think together. Let us think together and see what we can do. And see what we can do. And see what we can do. Right, we take a look and see what we can do. Let's look at the next one, the squares. We're looking at C for the square. Okay, let us look at the C. And so now we reason on the C and we look at what we need to do. And look at what we need to do. So now we might have cases where we need to sketch this one. So now I want us to look at the R squared carefully, ponder on it, and sketch it very well. To sketch this one, we investigate R squared equals 16 sine 2 theta. Which is 16 sine 2 theta. Which is plus or minus the square root of 16 sine 2 theta. Getting R is plus square root of 16 is a 4. The square root of sine 2 theta. Okay. Right. Right. We think about this. If we replace theta by negative theta, so we look at the symmetries. We do the symmetry tests. So these are the symmetry tests. We wrote them here. If we replace theta by negative theta and the graph remains the same, it is symmetric about the x-axis. But if you replace theta by pi minus theta and the graph remains the same, it is symmetric about the y-axis. Okay. If you replace theta by theta plus pi and the graph remains the same, or you replace r by minus r and the graph remains the same, then it is symmetric about the origin. So this is our investigation. Let's continue with the investigation. But now we deal with this. We deal with this. We deal with this. Okay, we deal with this. So now we're going to look at the graph. We're going to sketch the graph of this one and then the graph of the other one. But first, let us do the theta r. 0, pi over 2, pi, 3 pi over 2, 2 pi. A 0. 8 pi over 2, 0. Okay, you put pi over 2 here. But if you put pi over 2 here, then it's going to become what? It's going to become 2 times pi over 2, which is like pi. The sign of pi is 0. Then you put 2 pi is also 0. Very interesting. So everything is going to be 0. So this one is a tricky one. Because of the many zeros, then you can't sketch anything if everything is 0. Right, then you need to include some other things in the middle. You need to introduce some other things in the middle. Right. So it helps to then say, whenever this graph becomes 0, in other words, it helps to then say whenever the sine of 16 sine 2 theta becomes 0, which means the sine of 2 theta becomes 0, which means 2 theta becomes 0. Arc sine 0 becomes what? Becomes pi. Becomes exactly pi. So, and this would mean that it is at pi over 2. So indeed it is 0 at pi over 2. But now you need to attempt to take the steps in the middle. So need to draw another table and have theta r and then have 0, 0. Zero pi over 4. Pi over 2. We move in steps of pi over 4. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7. 7 pi over 4, 2 pi. 8 pi over 4, 2 pi. At 0, 0, 0, 0, 0, 0. We just have to come with the pi over 4 here. Like at pi over 4, then it's going to be pi over 2, which is going to become a 4. Okay, so we're going to first look at the positive. So first we sketch the positive, and then we're going to look at the negative square root. We do the positive 4, and we have actually exactly the sign of 2 pi. We have exactly the sign of 2 pi. Okay. So let us see now what we are doing here. So we're going to have the 3 pi over 4. In which quadrant is that? So sometimes it will help you to just look at this, and then you do 0. Then you do the pi over 4. You do the pi over 2, because you might do this without a calculator. This is pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4, 5 pi over 4. 6 pi over 4, 7 pi over 4. 8 pi over 4. So with this, you would actually therefore have the requisite analysis. Okay, you'd have the requisite analysis. You'd have the requisite analysis. We continue. We continue. Okay, let us think about this and make sure we understand this. Okay, now let us see what we can do. So we have this now. We just put, because everything was 0 here, so we take half. Okay, so we take between 0 and pi over 2, you divide by 2. You take pi over 2, you divide it by 2, it becomes pi over 4. Then you try that one. Then, with that, let us do the r theta. This one. Then you're going to do pi over 4. You do this step here. Pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then you have 2 pi. Okay. And then you have 4. Okay, let us see this one. Okay, obviously we're still completing the table. Like 3 pi over 4 is negative, is sitting here. Rather, the sign is positive there. Okay, so, but it is the same thing. It's going to be a 3 pi over 2, because you multiply 3 pi over 4 by 2, it becomes 3 pi over 2. The sign of 3 pi over 2 becomes what? Interesting. It becomes exactly a negative. So, which is non-real. And then at 5 pi over 4, which is here, the sign is also the 3 pi over, so it's going to be 5 pi over 2, and 5 pi over 2 is a positive, giving us a 4. And then at 7 pi over 4, it's going to be 7 pi over 2. 7 pi over 2 is negative, which is non-real, and then 0. At 0, it's going to be 0. At pi over 4, it is 4. At pi over 2, it's 0. At 3 pi over 4, it is non-real. At pi, it becomes 0. So this is going to be pi over 4, at pi over 2, it becomes 0. So you have this graph. So now the graph is non-real here, but at pi, then it becomes 0. At 5 pi over 4, it becomes a 1. So this is the textbook's approach to the things. So you just do the r theta graph, and then you do the polar. Okay. Then now you have the 3 pi over 2, and it's going to become 0 again. So the graph is just going to do some things, and then it's going to jump here because it's non-real. Because of the square root, now you can't have negative under the square root. Because if you put 3 pi over 4, then you have the square root of -1. What is this? Square root of -1 is non-real. It's a complex number. So we don't do complex numbers when we do polar curves. So now we're also going to continue with the 7 pi over 4, which is non-real. And then at pi, it's going to become, at 2 pi, it's going to become 0. But at 7 pi over 4 is non-real. So this is the sort of situation you have. This is the sort of situation you have here. Okay. So let us analyze this one. Now we are here to draw this graph using these small little shapes. Right. So it means that at 0, it is 0. You have 0, you have pi over 2, you have pi, you have 3 pi over 2, and then you have 2 pi radians. Then you have exactly 2 pi radians. 2 pi radians. We continue with our search. We continue with our search for the truth. Continue with our search for the truth. Okay, so at 0, you're going to be 0, you hear? And then now you move to pi over 4. It's going to be 4. Pi over 4 is like here. So there is radius for an angle pi over 4 radians. But what are we seeing? We're seeing that from 0 to pi over 4, the radius is increasing steadily. Right, so there's an increase in the radius. So from 0, the radius increases to pi over 4. When it reaches pi over 4, it starts decreasing as we move towards pi over 2. It starts decreasing as you move towards pi over 2. And then between pi over 2 and pi, between pi over 2 and pi, the graph is not there because you have non-real things. It's non-real there. Non-real. Non-real. Then at pi, the graph is 0. So at pi, you have 0. And then now, from pi to 5 pi over 4, 5 pi over 4 is here. Because you move pi over 4 to pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So at pi, it is 0. Then you move to 5 pi over 4, which is here. Then it's going to attain its maximum again. It's going to reach radius that 5 pi over 4. The radius now from pi, there it's actually increasing. So it is 0 here, and then it starts increasing. And then the radius will actually again start to decrease towards 3 pi over 2 there. And then we can see that at 2 pi radians, at 7 pi over 4 is non-real. Okay, there's 7 pi over 4 here, but it's non-real. There's nothing. At 2 pi, it becomes 0 again. So at 2 pi, it becomes 0. You are back there. and this is the graph. So look at how we've drawn this polar curve. Very easy. Very, very easy. Right, very, very easy. So think about this and make sure that you are able to understand these things. Then make sure that you are able to understand these things here. Right. I'm keeping it on the screen for a moment. You reflect on it. You think about it, because can you discuss the symmetry of this graph here? Right. Can you discuss the symmetry of this graph here? Okay. It is symmetric about which axis? Okay. That's a good question. When do you know when to use pi over 4? When do we know when to use pi over 4? Yeah, the secret is that pi over 4, it reaches its maximum. So you'd have to look at the fact that this is the graph of 2 theta. This is the graph of 2 theta. When will the sine reach its maximum? So you'll have to look at the fact that the sine of 2 theta has a maximum of 1. All the graphs of the cosine and sine have a maximum of 1. So you'd have to say it must be 1. This is a maximum. And if it must be 1, then you do 2 theta is arc sine 1. Okay, this is very important. So arc sine 1 becomes pi over 2. At 90 degrees, the sine is 1. You divide by 2. If you divide pi over 2 by 2, then you have theta equals pi over 4 radians. And this means that you have to use the step of pi over 4. So this is the hint. This is the hint. Okay. So you have to look at when the graph is going to reach its maximum. Then the minimum will actually be obtained in a similar manner. Will be you see, the minimum is going to be obtained in the process when you are analyzing the graph, and you tend to see, okay, right now, okay, because here there are 2 graphs. Let's discuss the fact that we focused on the positive. What about the negative? The negative is going to be the same, because it's just going to be obviously, if you sketch it here, it's going to be on this side. But now it's just going to be that this part is going to be here and this part is going to be there. So the negative is going to be the same for this. So now you just do one, and then the other one is the same thing. Okay, think about how we've drawn this shape. Try to understand this shape very well. Try to make sense of this shape. Try to make sense of this shape. Try to make sense of this shape and make sure you understand these things very well. Make sure you understand these things very, very well. Make sure you understand these things very well. Right. Let's move on to the next one. The next one is D. Let us have fun with D. Okay, let us have fun with D. So perhaps we need to also just look at the fact that you need to look at the maximum. So you look at D is as cosine, yeah? Just pick the trigonometric function, just pick it. Like you'll pick the cosine 2 theta, it must be 1. That is the maximum. All of them have a maximum of 1, minimum minus 1. So, okay, then you do the arc cosine. So it's going to be 2 theta. You do the arc cosine of 1, and then it becomes what? Which is 0. 0, 2 pi. Or then you're going to have theta equals pi. So there are 2 of them. So you can do step 0 pi. You're going to do pi. But obviously now we do steps of pi over 2 then. Okay. So let us look at this. So let us draw a little table here. Theta r, 0, pi over 2 radians pi, 3 pi over 2, 2 pi. So so you have that, but you'll have to take note of the fact that this graph is going to have, when is it going to be 0, this graph? Okay, you need to take note of that also, which means it's going to be 0 at arc cosine 0, which is pi over 2. Divide pi over 2 by 2, you get pi over 4. So we'll have to take pi over 4 for this one also. You can see that this one occurs at 0. The pi over 4. At this point, it doesn't occur at the maximum. So which means you have this one, which is pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. We continue. So now when r is 0, you put here it's going to be 2. At pi over 2, then it's going to be 0. Because you put the pi over 4 here, 2 times pi over 4 is pi over 2. The cosine is 0. And then this one at pi is going to be minus 2. Okay, but yeah, you need to take the square root because it's the squares. So there are some parts where this is not going to appear. Parts where it's going to disappear. Okay, so you have r squared equals 2 cosine 2 theta. take the square root of r squared plus or minus the square root of 2 cosine 2 theta. Meaning r is plus or minus. So you have the square root of 2, the square root of cosine 2 theta. So, but you're going to first do the plus. Okay, we're first going to do the plus. We're going to do 2 the square root of 2. We're going to do 2 the square root of 2. And then we see that one. Let us check it out. Let's check out 2 the square root of 2 and see what we've got. But, okay, let's complete this table. So we're going to just run through this table here. We're going to run through this table here. We're going to run through this table. Run through this table. Let us do this one. Okay, you do cosine at pi over 2. The cosine 2 pi, it's going to be cosine pi, which is negative. So it's non-real, this one. At 3 pi over 2, you have 0. At pi, it's going to be 2 pi. Okay, you see at 0, yeah, it's going to be the square root of 2. I've put an extra 2 here. It should not be there. Should not be there. So this must be the square root of 2 cosine 2 theta. This one. So we continue. We continue. At pi is the square root of 2. 3 pi over 4, 0. At 3 pi over 2, if you put that. 3 pi over 2, it's going to be non-real because it's going to be multiplied at 3 pi over 2 by 2, it becomes 3 pi. The cosine is negative 1. You can't have negative under the square root. But 7 pi over 2 is going to be also a 0. At 2 pi, it's going to be the square root of 2. Okay. We're just dealing with the positive, and then we're going to see what we get. So now you're going to do this graph. But first we do the r theta, and then we do the polar curve. Let us see now. You can see that here we have interesting things that are happening at 0. Okay. So this is 0. This is pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So you have these at pi over 4, it becomes 0. So now you're going to have this graph. But here there's going to be nothing at pi over 2 because it's non-real. At 3 pi over 4, it becomes 0 again. At pi, it's going to move to the square root of 2. At 5 pi over 4, it's 0 again. Yeah, at 5 pi over 4 it's 0 again. That's what we're saying. At 5 pi over 4 it's 0 again. So that's what you're going to have. 3 pi over 2 is non-real. 0 here. You have the square root of 2. Like this. Then there is a little tail here. Little tail here, like this. Okay, let's think about this one. So you can see that here the step is coming from the origin whenever it's 0. So it's either when it is maximum, but you can see that the maximum worked well for the sine, and then now for the cosine, it is only at 0 that we're able to get the correct step size of pi over 4 radians. Okay, so let us do the sketch. Y and X. At pi, at rather 0, pi over 2, 3 pi over the pi here only do pi. Okay. Three pi over 2, 2 pi. So you have the following. Okay, so yeah, let's just sketch quickly. At 0, it is the square root of 2. R is square root of 2 and 0 radians. And then you can see that the radius is decreasing to 0 at pi over 4. So this pi over 4. When at pi over 4, then it's going to decrease to 0. It's going to decrease to 0. And then there's nothing from pi over 4 to pi over 2. So this one is going to be at r is 0 at pi over 4. But from pi over 4 to pi over 2, there's nothing. From pi over 2 to 3 pi over 4, there's also nothing. How true is this? How true is this? You need to investigate this. Yeah. It is therefore 0 at 3 pi over 4. So this is 3 pi over 4, then it's going to be 0 at 3 pi over 4. At pi, it's going to be the square root of 2. At pi, it's going to be square root of 2, but it's negative. But now you can see there is sort of an increase there. And then from pi to 5 pi over 4, it's 0. R is 0 at 5 pi over 4 regions. So it's going to be 0 like this. There's nothing here up to 7 pi over 4. At 7 pi over 4, it is 0. 0 at 7 pi over 4. It is 0 at 7 pi over 4. and then add 0 to 7 pi over 4. From 7 pi over 4 is going to increase to the square root of 2. Okay. So this is a graph. This becomes the polar curve. So now we've sketched D. Think about it and make sure you understand it, because this is the way to sketch. So for the cosine, you can see that the step pi over 4 came when this cosine theta was equated to 0. But for the sine, it's when it was equated to the maximum that we were able to get the pi over 4 step size there. So this is very, very important, because now you think about it and make sure that we're good. And make sure that we're good. Right, and make sure that we're good. Okay, we're good. So this is okay, but yeah, the other things they want. I was not checking this. In each case, state the values of theta for which you have maximum, minimum, or 0. Also, these are very important. The maximum, minimum, or 0, because they give us the step. Like the step comes from the maximum, the minimum, or 0. So these are the things that become so important. So important. So important. Okay, like what is the maximum? What is the minimum? What is the maximum? The maximum, in each case, state the values of theta for which the maximum occurs. Like the maximum is going to occur like at 0. But you can see that it's also going to occur at pi. It's also going to occur at 2 pi. So the minimum is going to occur at what? Right. 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 We continue. Right. We continue. Right. Right. We continue. Right. So we continue. So yeah, and then okay, this is what. So we're saying the minimum. Where will the minimum occur? So obviously the minimum for this is, for instance, like the negative square root of 2, which happens at pi. You know, it happens at pi. That is where you have negative square root of 2, which is sort of the smallest one, smallest radius. And then now you have the 0. When is it 0? Right, the values of theta for which it is 0, like pi over 4. Pi over 4 it is 0, but also at 3 pi over 4 it is 0. At 3 pi over 4 is also 0, and so on and so forth. Okay, we can come here and do the same. And do the same like here. So what would be the Roman figure 1, the maximum? Roman figure 2, the minimum. Roman figure 3, 0. The maximum is going to occur at theta equals pi over 4 radians. 5 pi over 4. The minimum is going to occur at what? Good. Where we have the smallest value of r. So now it's something to think about here, of course. You'd be able to see, therefore, that the minimum value is going to occur at 5 pi over 4. So in principle, this must be a negative at 5 pi over 4. 0 is going to occur at 0. Okay, it's 0, but also like at pi over 2, you also have 0. And then also at pi, you also have 0. And so on and so forth. And also at 2 pi, you also have 0. Okay. Right. Let's continue with our search. Let's continue with our search. Let's continue with our search. Right. Let's continue with our search. We continue with our search. Let's see what we've got. Let us do, we've done D, let us do E. Let us do E. Let us do E. Right, now to do E is very easy. We're gonna do, where is it maximum, where is it minimum? And where is it 0? For E. So the maximum is gonna occur whenever you have cosine 2 theta is 1. That means whenever you have arc cosine 1, which is 2 theta is 0, or 2 pi, which means theta is 0 or pi. Where will it be 0 this? Cosine theta, where will it be 0? It's going to be 0 at 2 theta, which is arc cosine of 0, which is pi over 2 radians, which means that theta is pi over 4. Okay. So we continue. We continue. So we're going to take the steps over pi over 4. Now let us take the steps of pi over 4. Okay, taking the steps of pi over 4, we get the following. So you have theta r. You have theta r. And then you have pi over 4, pi over 2, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay. So we shall be sketching minus 2 cosine 2 theta. Then we're going to do r theta graph. We do pi over 4 radians. We do pi over 4 radians. Pi over 2. 3 pi over 4. Pi. 5 pi over 4. 3 pi over 2. Taking them from the table. 7 pi over 4. 2 pi. Okay, I'm following the textbook's approach to this, and I feel that is much easier. Okay, now we're going to just put 0 is minus 2 at 2 pi. 0 at pi over 2 is going to be 2. At 3 pi over 4 is going to be 0. At pi, it's going to be minus 2. 5 pi over 2 is going to be 0. 2, 0, minus 2. Okay. Let us take a look at this one. Let us take a look at this one. Right, let us take a look at this. Right, let us ponder on these and reason on these, but extra carefully, and see what we have got. So yeah, this one is going to have negative r's, so we need to put in the middle. Pi over 2. Pi over 2. 3 pi over 4 pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. 2 pi. Okay, 0 is minus 2. Right. So now you have this one, which is 2. 3 pi over 4 is going to be 0. At pi is going to be -2. And then at 5 pi over 4, yeah, okay, this one is supposed to be at 5 pi over 4 is 0. At 3 pi over 2, 7 pi over 4 is 0. And this is -2. Okay, this is the sort of graph we have for the r theta. So we're going to use this graph in the rectangular coordinates. So this one is said to be the graph in rectangular coordinates. Okay, this is the textbook's approach. It's not that I'm reinventing the wheel. So the textbook suggests that we sketch the graphs like this, which I believe is easier a little bit because you can just compare. Okay, let's look at the polar curve now. 0 pi over 2 pi, 3 pi over 2, 2 pi. At 0, you have -2. Now, if you have 0 and -2, then it's not just 2, it's -2. At 0, you have -2, so it's going to be here. Because it's going to be in the negative, on the negative side. So this is what you're going to have, but then it comes with 0. At pi over 4, it's 0. Yeah. 0 pi over 4 radians. At pi over 2, then it is 2. Okay. So then at pi over 2, it's going to be 2. At 3 pi over 4, it's 0 again. At pi, it becomes -2, which is going to be -2 at pi. Okay, now let's analyze this graph. From 0, from theta equals 0, then to pi over 4, then it is from -2 between 0 and pi over 4. This is 0 pi over 4, you can see a sort of decrease in the magnitude. So in other words, now from 0 to pi over 4, there's a decrease in the magnitude. When you're at pi over 4, it is 0, and then it starts again to sort of increase in magnitude to pi over 2, and then there's a sudden decrease in the magnitude again. From 3 pi over 4, which is this one, at 3 pi over 4 is 0, but from 3 pi over 4 to pi, it is 0, and then there's an increase in the magnitude. And then from pi to 5 pi over 4, which is this one, there is again, yeah, because it pi, from pi to 5 pi over 4, then there's a decrease in the magnitude up to 5 pi over 4. From 5 pi over 4, it's 0, and then there is a increase in the magnitude. To 3 pi over 2, there's an increase in the magnitude. It becomes 2, then there's a sudden decrease in the magnitude up to 7 pi over 4. 7 pi over 4. And then there is a sudden increase in the magnitude. From 7 pi over 4, it is 0, but there's an increase in the magnitude to 2 pi. So that gives us this one for E. And so now there is the maximum, the minimum, and 0. So where do we have the max? It is 2. The minimum is going to occur at minus 2. Okay, the theta for which you have the maximum, you have seen that the theta for which you have the maximum is, for instance, like pi over 2 and many others. So you're able to see that at pi over 2, at theta equals pi over 2, you have the maximum. And then you have at theta equals pi, you have the minimum, but also at theta equals 0, you also have the minimum. 0, where is the curve 0? It is 0 at pi over 4, and so on and so forth. Okay. Right. So we continue. Right. We continue. We continue. Let us look at F, for example. Right, so F now, we'll play around with it. We're going to look at the maximum. It's going to occur when cosine 3t theta is 1. Which means arc cosine 1. And then now, which is pi out of, okay, the cosine is it's 1 at 2 possible angles at 0 and 2 pi. 0 and 2 pi, which means that it's going to give us, you divide by 3, you have 0, 2 pi over 3. But where do we have that this is 0? Cosine 3 theta equal to 0 would mean that 3 theta is arc cosine 0. And arc cosine 0 is pi over 2. Plus or minus pi over 2. And therefore, theta is plus or minus pi out of 6. Okay. So now we're going to take pi out of 6 there. It's the smallest step we've got. Let us draw a table. theta r. 0, pi out of 6. Two pi out of 6. 3 pi out of 6. 4 pi out of 6. 5 pi out of 6. 6 pi out of 6. 7 pi out of 6. 8 pi out of 6. 8 pi out of 6. 9 pi out of 6. 10 pi out of 6. 11 pi out of 6. 12 pi out of 6. 0. This is going to be a 1. Okay, but yeah, I'm going to take the square root because it is r squared equals cosine 3 theta. Then we're going to deal with r equals plus or minus the square root of 3 theta. So we continue. We continue. So we continue. So we continue. So we continue. So when this is 0, then it is 1. Square root. This one is going to be 0. You put this one. And then this one is going to be non-real. 3 pi over 2 is going to be 0. 2 pi over 3 is going to be a 1. 5 pi out of 2, 0. Non-real. 7 pi out of 2, 0. So this is 1. 9 pi out of 2, which is 0. Non-real. 0, 1. Let us sketch the r theta curve. So you have 0, pi out of 6, pi out of 3, pi out of 2, 2 part of 3, 5 part of 6, 7 part of 6, 4 part of 3, 3 part of 2, 5 part of 3, 11 part of 6, 2 pi. It's 0, then it is 1. 5 part of 6, then it is 0. 2 part of 3, then it is 1. 5 part of 6, then it is 0. Non-real. 7 part of 6, it is 0. 4 part of 3, it is 1. 3 part of 2, it is 0. This is non-real. 11 part of 6, it is 0. 1. So now let us sketch this one. So at 0, it is 1. 1, 0. R theta. And then this graph to pi over 6 is going to decrease. So it's going to be pi of 6 here, and then it's going to decrease like this. And then now there's going to be no graph. Even up to pi over 3, then from pi over 2 to 2 pi over 3, the graph is going to, pi over 2 is this one. It's going to be 0. Two pi over 3 at pi over 2 is going to be 0. From pi over 2 is going to increase to 1 at 2 pi over 3. And then from 2 pi over 3 to 5 pi over 6 is going to decrease again to 0. At 7 pi over 6, which is this one, it's going to, it is 0. And then it's going to, because pi over 6, yeah. At 7 pi over 6 is going to be 0. And then up to 4 pi over 3. Yeah. Which is 4 pi 60. 4 pi 60 is like 240. 4 pi 60. Because this is, yeah, it's going to be a 1, but it's going to start from 7 pi of 6. Up to 4 pi over 3. It's going to be a 1. And then it's going to decrease towards 3 pi over 2. This one is going to be 1 at 4 pi of 3. 1. Okay, and then now we're going to have this one. It's going to be non-real here up to 11 pi of 6. Which is going to be 0. Then it starts increasing, which is going to be 0. And then if it's 0 here, it starts increasing towards 2 pi. Something this way. So this deals with the positives. But now, this graph is symmetric with respect to when you replace theta by negative theta, the graph is the same because the cosine is an even function. So there's symmetry about the x-axis. x-axis symmetry. Right, so there is this x-axis symmetry. X-axis symmetry. Okay. Which means also this one. Okay, symmetry about the x-axis if you replace theta by negative theta. But you replace theta by pi minus theta produces the same equation. Replacing theta by theta plus pi produces the same equation in r by negative theta. There's a symmetry about this, so you investigate this one. Cosine of 3 pi minus theta is cosine of 3 pi minus 3 theta. Okay, 3 pi minus 3 theta is actually going to be negative. So there's no symmetry there about the y-axis, but there's symmetry about the x-axis. Is there symmetry about the origin? There's no symmetry about the origin as well. So the symmetry about the x-axis. Let's check that out. So now with symmetry about the x-axis, then it means therefore about this x-axis, there's symmetry so that this image here is going to be also available there. All right, so the symmetry about the x-axis so that if you actually look at what is happening above here, it must happen exactly at the bottom, meaning this one must also be there. Right, and also this graph that is the, and also this one, because you're also going to have the negative graph. So it's going to have this and it's going to produce the negative loop on the negative side for this. So it's going to produce the graphs of God, but also the negatives as well. In other words, we have also taken into account the graph, which is r negative the square root of cosine 3 theta. But now you have the following. You have exactly the following. So this is the graph of this one. But what is the maximum? Right, you can see that the maximum is 1. And it occurs at theta equals 0. There's a maximum. There's a minimum. The minimum occurs at, it is 0 at pi over 6. And other angles. The minimum occurs when it is negative. But you can see that the negative, for instance, occurs at some angles. Right, and the minimum, because now this graph has a negative, you can see that whenever theta equals pi, then you have a minimum. As much as obviously this is undefined there, but we have an image of that. So the minimum, therefore, is going to also occur at theta equals 0. At theta equals 0 for the negative square root. For the negative square root of 3 theta. Okay, we are done with our discussion. I must thank you for joining us. It was awesome having this discussion. I have another discussion right now at 10 o'clock. So, yeah, I need to actually plan for that one. So I'm gonna send you the recording, but yeah, I'm gonna send the recording after 4 hours, so that will be after 2, because I have a discussion now that is going to be running. So there's no way I'm gonna send the recording then, but I'm gonna send it by 2. And when I send it by 2, we're gonna start again. Yeah, when I send it by 2, we're gonna start again, and then we're gonna do more of the polar caves and the other things. But thank you for joining us. Yeah, until 2 o'clock when I send the recording and we continue with our discussion. Thank you. Take care. Goodbye.